So last week, what did we do? We have started a convergence and divergence concept. So recall. So limit of the sequence. This is what we have discussed. Limit intending to infinity sequence Sn. Sequence is denoted either using flower bracket or this symbol or this symbol. So any one of the symbols, then limit of the sequence is limit of the nth term. So limit need not be unique. It can be infinity, finite, infinite, anything. It should be finite or infinite, or it could be more than one limit. Need not be unique. We have seen many questions. So for limit to exist, even if it is infinity also, we say it exists. For example, what is limit tending to infinity and n square? What is the answer is infinity, because infinity square is infinity. You should not write it does not exist. It exists and is infinity. Even if it is minus infinity also, we say it exists. Some students, if they get minus infinity, they are concluding that it does not exist, but it exists and is minus infinity. And sequence may get more than one limit also. For example, the sequence Sn, where Sn is either 0 or 1. The sequence Sn is 0, 1, 0, 1 like this. Then nth term will be either 0 or 1. Where? Then in this case, limit will be either 0 or 1. Is it not? So it will be equal to 0. It will be equal to 1. Sometimes 0, sometimes 1. So it is finite, not unique. But even then, no problem. It exists. Exist, we say. Or limit can be unique also. 1 by infinity, 0. Unique. Finite, unique. So you may get any one of these cases for limit. Still we say limit exists. Okay. So even if we get infinity also, we say it exists. Minus infinity also exists. Then limit exists. But when do we say it is convergent? This concept we have seen. Sequence Sn is said to be convergent if and only if limit is finite and unique. Very important. For limit to exist, it need not be unique. It need not be finite. But for this to be convergent, limit L, limit of the sequence, is finite and unique. Then we say it is convergent. Divergent, if limit Sn is infinity or minus. So if it is infinity also, we say divergent. Sequence is divergent if limit Sn is infinity or minus, in both the cases. Sequence, limit of the sequence is minus. In this case also, we say it is divergent. Next is oscillator. When do we say it is oscillatory? Under this, we have two types. Oscillates finitely oscillates infinitely. When do we say it is oscillates finitely? If sequence Sn, limit of the sequence, it is finite, not unique, then we say oscillates infinite, oscillates finite. So limit of the sequence is finite but not unique. For example, here, this is finite. We are getting limits as either 0 or 1. Finite, not unique. So we say this sequence oscillates finitely. This is divergent sequence. This is divergent. So because infinity, the sequence n square diverges. The sequence minus n square diverges, we say. It diverges to infinity, this diverges to minus infinity. These two are divergent sequences. This is convergent because limit is finite and unique. So, next. If limit sequence Sn is infinity sometimes and minus infinity, both you are getting. That is, it is not finite, not unique. Not finite, not unique. Here finite but not unique. Here not finite, not unique. Then we say the sequence Sn oscillates infinite. Oscillates finitely means finite, not unique. Here not finite. So you get infinity and minus infinity. If you get infinity alone, divergent. If you get minus infinity alone, divergent. If you get both, then it oscillates infinite. Here you can see. If this is infinity, divergent. If it is minus infinity, divergent. But if it is both, sometimes infinity, sometimes minus infinity, if you are getting both, then it oscillates infinite. Next one. Let us, and sometimes if limit Sn is infinity, sometimes and finite, some number you get. If it is both infinity minus infinity, then in that case it oscillates infinitely. Infinity, if both are finite, oscillates finitely. But if one of them is infinity or minus infinity and other is finite, then we say Sn has mixed divergence. So keep all these points in the mind. Whether you have attended or this is the first class, this is the story. This is what we have done in the previous classes. One more we stated, whenever we have two sequences, if sequence Sn is bounded, one of them, any one of them, that is mod Sn is less than or equal to some k, and limit of the sequence is 0, one of the sequences, then limit Sn Tn. One of them is bounded, the other limit is 0, and the product is, limit of the product is 0. So let us put some questions. Patience. So test the convergence And as I said, whenever you get minus 1 power n, always divide into two cases. Plus 1 if n is even, and is minus 1 when n is odd. So we keep all these in the mind while doing the problems. So test the convergence of Fn, sequence Fn, where Fn is given by. So sequence is denoted by S suffix n, or sequence is denoted by Fn or F suffix n, some notation. The nth term of the sequence is given by this. So is it convergent or not? We are asked to test. So how to proceed for this? First, we find out, divide into cases. Minus 1 power n is there, so divide into two cases. So limit of the sequence is limit of Fn. This is the formula. Limit of the sequence is limit of its nth term. So first case, if n is even, then Fn will be. First, let us simplify. Minus 1 power n becomes 1. Minus 1 power n becomes 1. Right. Find out limit. Limit n tending to infinity, 1 by n. 2 by 2 is 1. 1 plus 1, 2. 2 by 2 is 1. This is 0 plus 1. Therefore, limit of the sequence is Fn is 1 if n is even. Let us go for odd case. So if f of n, if n is odd, then f of n will be minus 1 power n will become minus 1. So here minus 1, here also minus 1. So minus 1 by n, 1 minus 1 by n, by 2. By 2. So this will be simply minus 1 by n. F of n is minus 1 by n. So what is limit Fn is, it will be 0. Minus 0 is 0. Therefore, we are getting limit of the sequence Fn is limit Fn and is 1 if n is even, 0 if n is odd. Therefore, sequence f of n oscillates finite. So in the exam, you can skip many steps because as a teacher, I cannot skip, but as a student, you can. By looking at them, you can decide. So because no one sees the steps, because yours is MCQ, some of you can skip all these steps. By looking at them, you can write that. One time you get this is 1, this is 1, 1 by n, 1 plus 1 by 2. So 1 by n is 0, 2 by 2 is 1, limit is 1. N is odd, this is minus 1, minus 1 by n, limit is 0, 1 minus 1 is 0. So like that, by looking at that, without putting pen on the paper, you can answer. But for you to explain, I am doing all this. You can skip. You need not write all the steps. So it is finite, but not unique. So it oscillates finitely. Or among options, you may be given oscillate, oscillates, or the sequence is oscillatory. So if it oscillates, we say the sequence is oscillatory. The sequence is oscillatory. So this is how it is. Take second. This is f of n given in many cases. This sequence f of n, where f of n is 2 power 1 by n. Or you may be given directly the sequence 2 power 1 by n ranging from 1 to infinity. Or in the exam, you may be given 2 power 1 by 2, 2 power 1 by 3, and so on. So what can you say about all this such sequences? So what we have to do? Find out the limit. So limit of the sequence is limit of 2 power 1 by n. As n tends to infinity, 1 by infinity is 0, which is finite and unique. Finite and unique. So this is finite and unique. Therefore, sequence is convergent. Is convergent. Let us see another question. N power minus 1 by n. Very interesting question. N power minus 1 power. What can you support? So divide into two cases. N power minus 1 power n. As I said, whenever and wherever you get minus 1 power n, divide into two cases. It will be equal to n power 1 minus 1 power n is 1 if n is odd, if n is even, and is equal to n power minus 1, which is 1 by n if n is odd. So what is limit of the sequence Fn is limit and tending to infinity n, which is infinity if n is even, because limit of the sequence is limit of the nth term, and is equal to limit 1 by n as n tends to infinity is 0 if n is odd. So you'll be given among options. Which option correct? Is it convergent? Option A, convergent. Option B, divergent. Option C, oscillates finitely, oscillates infinitely, mixed divergence. Which is correct option? Any one of you, can you tell? Is it convergent,
E, ma'am.
divergent, oscillates finitely, oscillates infinitely, or mixed divergence? What is your answer?
Mixed divergence.
Mixed divergence, correct. So because one of them is finite, the other is infinity. If you get infinity minus infinity, and one of them is finite, need not be 0 only. It can be 1, 2, 3, and so on. Then it oscillates. It is mixed divergence. Suppose you get infinity minus infinity, then oscillates infinitely. Suppose you get 1 and 0, then oscillates finitely. Both infinity, then divergent. Both minus infinity, divergent. Both finite and same, then converge. So keep this in the mind. Then you can answer the questions correctly. Mixed divergence. Many of you might not have seen this. And another question is sequence f of n, where f of n is n power 2 by 3, sin n factorial divided by n plus. So what can you say about this sequence? Is it convergent, divergent, and how to handle this? So we have to find limit Fn, the limit of Fn. So this is containing two sequences. This is looking like whenever you get sine and cos, remember, divide into two parts. Like minus 1 power n means and even and odd. Here, whenever you get sine and cos, do them separately. So this is the one. This is looking like Sn and Tn, two sequences. So, you know, limit n tending to infinity of Sn is limit n tending to infinity of n power 2 by 3 by n plus. If you do directly, you will get infinity by infinity. So do something. Take maximum power common from numerator as well as from denominator. So numerator, nothing to take common. Denominator, you take maximum power n. This is n power 1. So you can get it down. This is limit n tending to infinity 1 by n power 1 minus 2 by 3. 1 by 3. 1 plus 1 by 1 minus 2 by 3 is 1 by 3. As n tends to infinity, this is infinity power, this is 0. Because we have seen limit 1 by n power alpha 0 when alpha is positive. 1 by n 0, limit of this, 1 plus 0. This can be rewritten in the form. If you want, we'll write like this, separately. Limit of Fn Sn into this is this. Then separately. An into Bn is An into Bn. This is 0. Standard limit. 1 by 1 plus 0. 1. 0 into finite element is 0. So one of the sequences limit is 0. And limit Tn. What is Tn is sin n factorial. It is bounded. You know, sin theta, whatever may be your theta, in place of theta, you're having n factorial is always less than equal to 1. Sin of anything less than or equal to 1. Cos of anything less than or equal to 1. But tan of anything is not less than or equal to 1. Sin and cos, whenever you get, you can use this inequality because sin theta modulus is always less than or equal to 1. It is bounded. Therefore, one of them is bounded. One of them is bounded. Limit of this is 0. In the beginning, we have discussed. If whenever you are having product, one of them bounded, one of them limit 0, then limit of the product is 0. So limit Fn is always 0. Therefore, sequence f of n is convergent. Very, very important.
Ma'am, one doubt.
Yeah.
Here in evaluating Sn, ma'am, that is n to the power 2 by 3 by n plus 1, we can't go for a hospital rule.
You can, but L hospital rule you don't know. No. You have to differentiate with respect to n then. If you want to apply L hospital rule, you have to differentiate with respect to n. So n power 2 by 3 is 2 by 3, n power 2 by 3 minus 1. And the denominator d by dn n is 1, d by dn 1 is 0. So you will get the same limit 0. You can apply.
We can, okay.
You can. But with respect to n, you have to.
Yes.
Okay.
Okay, ma'am. Thank you.
Next one. So next question is f of n is sequence fn, where f of n is 3 power n plus minus 2 power n by 3 power n plus 1 plus minus 2 whole power n plus 1. So what can you say about this sequence? So how to work out this is, see, whatever we are doing, no two are same, all are different models. So if we come across any such, please start practicing. This is limit 3 power n minus 2 power n 3 power n plus 1 can be written as 3 power n into 3 minus 2 power n into minus 2. So we are having one standard limit. What is the standard limit we are having? Limit r power n is 0 whenever mod r less than 1. This we have seen earlier. So we want to apply that limit whenever to the power of n is given. So try to reduce to this form. So how to get less than 1 is always divide by greatest among them. 3 and minus 2, greatest is 3. So divide each and every term by 3 power n. Each and every term. You can skip all these steps in the exam. For you to explain, I am doing. Directly you can jump to this next step. 1 plus minus 2 by 3 whole power n, 3 plus minus 2 by 3 whole power n minus 2. You know, limit r power n is 0 whenever mod r is less than 1. R is minus 2 by 3. This is in the form r power n mod r less than 1. How do you know less than 1? Numerator less than denominator. Numerator less than denominator means less than. So limit of this is 0. So therefore, limit minus 2 by 3 whole power. So 1 plus 0, 3 plus 0, 1 by 3, which is finite and unique. Finite unique means automatically it is convergent. This is another model. So whenever you get to the power of n, use this mod r power n, because modulus of r is less than 1. Next, let us go for next question. F of n where f of n is root n plus 1 minus by bn comparison test, limit comparison test, and so on. But this is not series. Series means summation will be there. If flower bracket is there, it is sequence. Summation is there, series. So whatever test you have seen, limit comparison test, then ratio test, Cauchy's nth root test, all are applicable for series, not for sequences. So in your sem examinations, generally, you don't do many questions from sequences. So students, remember this standard question. Without this, you are not here. This is such an important question for series. This series, summation, if it is there, apply that. So here we are doing sequences, so don't apply those tests. So be careful. Wantedly, questions are given having similar type of n terms. Be careful. So if you apply limit directly, You will get infinity minus infinity. Infinity minus infinity. Don't cancel and say 0. Infinity minus infinity is not 0. 2 minus 2, 0. 3 minus 3, 0. If it is finite, you can cancel. This infinity, infinity minus infinity is indeterminate. So we cannot apply directly. Directly we cannot say 0. So what we have to do? Rationalize it. So try to rationalize. Root n plus 1 minus root n. So rationalize. N plus 1 minus root n. N plus 1 plus root by root n plus 1 plus root. So f of n is a plus b minus a minus b, a square minus b square. This is n plus 1 minus n by root n plus 1 plus root. So as n tends to infinity, one by n plus 1 plus root n. As n tends to infinity, this is 0. Infinity plus 1 infinity root infinity 0. This will become 0. So limit is finite and unique. Want you can do some decorations, take root n common, 1 by root n 0 like that. But in your MCQ point of view, not required. Sem point of view required. Don't write directly 0. Take root n common and do the formalities. So this is 0 because infinity plus 1 infinity, root infinity is infinity, infinity plus infinity infinity, 1 by infinity 0. So this is 0, finite and unique. Therefore, sequence Fn converges. But whereas if you take series, summation, if you remember, summation, those who remember, this is summation, then 1 by root n will take common, 1 by n power p. Root n means p is equal to 1 by 2, less than 1, less than 1 converges, greater than 1. There you have some test. P greater than 1 converges, less than 1 diverges. According that, it is divergent. If it is series, it is divergent. It is sequence, convergent. Be careful. So students, they apply that P test and all, they get it as divergent. That is for summation. Summation is there, go for that method. Here it is sequence. So don't use those techniques. Be careful, you get opposite results. So this converges. Next question. Pointedly, similar type which you have done in series will be given to you just to like divert your mind. So let us go for f of n, where f of n is log n to the base a divided by n, where a is greater than 1. So let us see. F of n log n base a. What is log n to the base a is log n by log a. Because log of b to the base a is log b by log a. So this is 1 by log a out. F of n log n by n. This is constant. Now we have to find limit. As n tends to infinity, if we apply directly 1 by log a limit n tending to infinity log n by n. This is log infinity, infinity by infinity. This is infinity by infinity. As somebody said, whenever you get 0 by 0 or infinity by infinity, you can apply L-Hospital rule. What is L-Hospital rule? Whenever you get 0 by 0 or infinity by infinity, differentiate numerator separately, denominator separately. Don't apply u by v. Separately, you have to differentiate and then apply limit. As n tends to infinity, 1 by n, log n is 1 by n, and d by n is 1. 0, which is finite and unique. Finite and unique. Therefore, sequence Fn, which is log n to the base a by n converges. Next, another interesting result. All these are repeated in some exam or the other. So sequence f of n, where f of n is n into a power n, where mod a is less than. So if you take limit as before, because mod a is less than 1, implies limit a power n is 0. We have seen standard result earlier. Let us use that. So limit n tending to infinity sequence Fn is limit n tending to infinity of f of n, limit n tending to infinity of n into a power. So limit n tending to infinity n is infinity into 0. This is it. So this is indeterminate. But you cannot apply L-Hospital rule. L-Hospital rule is only for standard indeterminate forms. Which are standard indeterminate forms? 0 by 0 and infinity by infinity. If they are 0 by 0 or infinity by infinity, you can apply directly. But if it is in the form infinity into 0, it is indeterminate, but we cannot apply limit directly. We have to convert them into either 0 by 0 form or infinity by infinity form. So the procedure for this is, whenever you get infinity into 0, the limit, then limit of fx into gx is infinity into 0. Then the procedure is, then write any one of them as reciprocation. Either write gx by 1 by fx without changing the question, because this will go to numerator, you will get this. In this case, gx limit is 0, fx limit is infinity, because fx is infinity, gx is 0 limit, 1 by infinity becomes 0. 0 by 0 form you will get. So that you can use L-Hospital. Or x. You can also write limit x approaching infinity. It need not be infinity only, it can be any a. Then you can rewrite it as fx by 1 by gx. So x tending to infinity, fx is infinity, gx 0, 1 by 0 infinity. So you get infinity by infinity. In either of the cases, you can apply L-Hospital. So which one to reciprocate? That is where you have to use your intelligence and your experience. So let us see which one to. If you take 1 by n, if you reciprocate this, this is your fn, this is your gn. 1 by n, if you write 1 by n, if you keep on applying L-Hospital rule, 1 by n, next time minus 1 by n square, next time 2 by n cube. Like this, it increases. But the idea behind this changing is it should reduce. The power should reduce. So if you take n, this formula 1 by n, then it will never be, it will be recursive, it will never end. So better to differentiate a power n. So whenever you get polynomial like this, always reciprocate the other function. Which one to reciprocate? That you have to decide. So limit a by 1 by 1, not 1 by n, sorry, n by 1 by a power. So I have done a power n as 1 by a power n because this formula I'm using. Because 1 by x is itself. We are not changing the format, but we are changing we are not changing the question, we are changing the format. We are rewriting the given one without disturbing the given question. Now apply L'Hospital. So differentiate numerator separately because this is infinity. You know, limit a n is 0, 1 by 0 is infinity. So I can go for L'Hospital rule. Then this is d by dn n, d by dn a power minus n plus 1 by a power n is that. This is limit n tending to infinity. D by dn n is 1. You can see the power is reducing. This is in the form a power x. For a power x, what is the derivative? A power x into log e into d by dn minus n. Because you are not having n minus n. That also at the function. Which formula I'm using? So simplify. A power minus n will go to the numerator. A power n it becomes log a. D by dn minus n is minus. A power n is 0. 0 by log a is 0. Therefore, this sequence n a power n converges. Because you are getting finite and unique. Therefore, this diagonal converges. Converges to 0. So let us go for provided mod a is less than. Because you are given this condition. We have used limit a power n 0. Because mod a is less than 1. It is given for us. So let us go for another type of question. F of n is equal to 1 lakh. So appears to be very big number, but very simple to do. So limit of the sequence is limit fn, which is limit so what you have to do, if you apply directly, you are getting infinity by infinity. So you can use L'Hospital rule, or you can divide by n square and do it. You have two options. Go for L'Hospital rule, or you can divide. This is a big number. Knock this out. This has nothing to do with that. Divide by n square. Each and every term. Highest power. 1 by n. Yes. So as n tends to infinity, 1 by n is 0. This is 0 plus 1. So 0 by 0 plus 0 by anything 0, 0 into anything 0, which is finite and unique. Therefore, sequence Fn converges. So don't be afraid of big numbers. You can, very simple at times. Next, another question. Sequence f of n, where f of n is 1 plus 2 by n whole power n. Let us. So, limit fn limit 1 plus 2 by n whole power n. This is limit 1 plus, I have given one standard limit. If you remember, this is e power x standard. So instead of x, you are having 2. So this becomes e square, which is finite and unique. This standard limits you need to remember. So therefore, what is e? It is 2.71 and so on, irrational between 2 and 3. Therefore, limit f of n converges. This is your f of n converges. The sequence converges. Because limit is finite and unique. Let us do. They appear to be simple, but if they come in the exam, you cannot do it. Doubt. F of n is 1 plus n by n plus 1 cos n pi by 2. Look at the question. It is not whole, only for this cos n pi. So, how to work out? So, you are having two options now. So, first we have to simplify cos n pi by 2. Because it is cos n. Had it been cos n, we would have used mod cos theta less than or equal to 1. If it is n alone, then you have to use mod cos theta less than or equal to 1. But if along with n, for example, sin n factorial we got, in that case, we had to use that. But here we are having along with n some pi by 2. So only n means use that. Along with n some angle is given, then simplify first. First simplify, then apply limit. So let us cos n pi by 2. What are the values? Let us see. When n is 1, what is the sequence actually? F of 1. What will you get? The sequence Fn is f of n. You have to divide into cases. What is cos n pi by 2? Let us do it separately. When n is 1, cos pi by 2. N is 2, cos 2 pi by 2. N is 3, cos 3 pi by 2. N is 4, 4 pi by 2. 5 pi by 2. Like this. So what is this equal to? Cos pi by 2, 1, 0, sorry. Cos pi minus 1. Cos 3 pi by 2, 0. Cos of odd number of times pi by 2, 0. So even number, you have to calculate. This is 2 pi. Cos 2 pi is 1. So this is 0. This is minus 1. Cos pi is minus 1. Cos 3 pi by 2 is 0. Cos 2 pi is 1. Cos 5 pi by 2 odd number. So 0 and so on. So you will get minus 1, 0, 1. So sometimes 0, sometimes minus 1, sometimes 1. Use that. So what will be your f of n is? It will be 1 n by n plus 1 into 0. Some cases for some values of n. And it will be equal to 1 plus n by n plus 1 into minus 1 in some cases. It will be equal to 1 plus n by n plus 1 into 1. Some cases. So, what is the limit that we have to find? So, limit n tending to infinity fn. First case, 1. Second case, n by n plus 1. If you apply directly, you will get infinity by infinity. So, take divide by n. Divide by n. 1 minus 1 by n limit is 0. 1 plus 0 is 1. 1 minus 1, 0. And third case, 1 plus n by n plus 1 by 1 plus n by n plus 1 limit will be 0 like here. So this will be limit 1 plus 1. As n tends to infinity, 1 by n is 0. 1 plus 0 is 1. 1 by 1. So 1 plus 1, which is 2. So you are getting the limit as 0, limit as 1, limit as 2. So what are the limits you are getting? 1, 0, 2. So limit of f of n, you are getting it as either 1 or 0 or 2. They are finite but not unique. Therefore, oscillates, the sequence oscillates finite. Okay. Let us go for next. So no two are same. Some students they do cos is bounded, therefore something and all you get some other conclusion, opposite conclusion. So you should be very, very careful. So we have some more questions based on this you are getting in the exam again. So the questions which you have not seen in your academics that I am doing particularly. So important is if Sn is 1 by n, use this as some instruction, important formula. 1 by n, this is k equal to 0 to n minus 1, f of k by n, and Tn is equal to 1 by n summation 1 to n f of k by n. If your question is like this, then the sequences Sn and the sequence Tn converges. If they are in that form, they are converges to 0 to 1 fx dx. Very important. So remember here, what is the difference between Sn and Tn? Outside 1 by n, inside f of k by n, 0 to n minus 1 or 1 to n. Total range is n. That is 0 to n minus 1 also, number of terms are n. 1 to n also, number of terms n. So inside term should be n in number. Number of terms n. So let us see the application given in many papers again. So limit n tending to infinity 1 by n summation k by n whole square is dash, given in many papers. Or the question may be given like this. Limit n tending to infinity, just to confuse. You may give the question 1 by n whole square, 2 by n square, n by n square is dash. So you get such questions in the exam. Then how do we calculate? This is in which form? This is in the form 1 by n, 1 to n, that is Tn form, f of k by n. Wherever k is there, you are having k by n. That you have to identify. How will you identify this model? Okay, because I am doing under this concept, you will remember. Suddenly, if it comes in the exam, how will you remember that you have to apply this? The idea that should strike your mind is, you are having wherever k is there, k by n. And range is 1 to n. So, let us see. This is limit n tending to infinity. 1 by n f of k by n. K equal to 1. This is, it will converge to 0 to 1 fx dx. Converge to formula. That means it is equal to, converges to means it is equal to. So it is equal to 0 to 1 fx dx. What is f of k by n here? K by n square. So 0 to 1 fx dx. X cube by 1 by 3. Lower limit is 0. So the answer for this is. Okay. So very important. Such questions. So first identify that. If nth term is not given, if it is given like this, okay. Not given, if it is given like this, you have to transform this question to this form. That is, identify the nth term. First term 1 by n, second term 2. That you have to predict k by n. So k by n square summation. And then it is in the form f of k by n. What is f of x? Replace k by n by x. 1 by 3 is the answer. So let us go for a few more. Limit n tending to infinity. 1 by n plus 1. 1 by n plus 2. 1 by n plus n is dash. You find in many papers question like this. Definite. So this is limit n tending to infinity. We have to write nth term. First term n plus 1, second term n plus 2, nth term n plus 1. So kth term will be n plus k. So this is limit n tending to infinity. We want 1 by n. What is the form that is required? We want 1 by n outside summation f of k by n. So take 1 by n out. Summation n common 1 plus k. This is limit n tending to infinity. 1 by n summation 1 by k plus k by n. This is in the form f of k by n. Summation k equal to 1. F of k by n means wherever k is there, you are having k by n. One by. So this is 0 to 1 fx dx. F of x is zero to 1. Apply upper limit minus lower. 1 plus 1 is 2. Log 1. 1 plus 0 is 1. Log 1, 0. So this is convergent to this. Convergent means that is equal to. So what is the answer for this is log 2. So let us do some more questions based on this. Limit square plus k square. Yes. Dash.
మొన్న సిఎస్ఐఆర్ జూలైలో వచ్చింది మేడం ఈ మోడల్ క్వశ్చన్.
Definite questions. Limit. This is in the form 1 by n, we have to reduce it. How to reduce it? Take maximum power of n common. So this is limit 1 by n summation 1 by 1 plus k by n square. Sequence. This is in the form limit 1 by n f of k by n, where f of k by n is 1 plus summation 1 plus k by n square. So fx is replace k by n by x. 1 plus x. What is this equal to? 0 to 1 fx dx. 0 to 1 1 by 1 plus x square dx. This is nothing but tan inverse x. Limits are from 0 to 1. Tan inverse 1. Pi by 4, 45. So what is the answer for this? Pi by 4 is the answer. Next. No two are same. So I'm not able to leave. Limit n tending to infinity. Summation k equal to 1 to n 1 by root n square plus k. So, how will you solve this? We have to write it in the standard form. 1 by n we want. So take a maximum power of n common always. Which is limit one by n 1 plus k by n square. So 1 by n f of k by n. Where k by n is 1 by 1 plus k by n square. So what is f of x is root 1 plus x. So this is 0 to 1 fx dx. We have seen this converges to this. One of you, can you tell me? Somehow you can come up to this. What is this? What is integral 1 by root 1 plus x square?
Sin H inverse actually.
What is
Sin
Amma?
H inverse.
Sin h inverse x? Sin h inverse 1. H inverse 0 is 0. This you will get by great difficulty. But this will not be given among options. Options will be in terms of log. Log of root 2 minus 1, log of root 2 plus 1. Like that, options will be given to you. This will not be given among options. Then what is the relation between this and log? Any one of you, can you tell me?
Log of x 1 plus
So what
Log
is
of
sin?
x plus under root of x square plus a square.
square.
This is log of
X plus
X plus under
square
root
root
x square plus a square.
of x square.
so what will you get?
1 plus
1 plus
1 plus x square.
Correct, good. This is 1 plus x square. So you should be very perfect in your basics. So this formula you will not get. It is there in the intermediate. So if you have some like grip over the basics, it would be very easy. Because inside that intermediate question is there. You have done all this. Log can be written as ln or log. You may be given either log or ln. Ln is log base e. So among options, ln may be given, log may be given. Log to the base e is called ln. Apply now. This will be 1 plus root 1 plus 1 square, which is, this is ln 1 plus root 2 or log of 1 plus root 2. It's the requirements. I think you might have seen this in some question papers. All these questions are repeated somewhere or the other. Next question is limit. If I had left this, you would not have got this idea. 90% of the students, they will also leave after getting sin h inverse 1. So look at the options. Among options, it is in terms of h, it is in terms of answer. This is the form. This is the form. Here is the form. This is 1 by now. Summation is pi into k by n. So fx is sin pi x. So this will be 0 to 1 fx dx. 0 to 1 sin pi x dx. This will be minus cos pi x by pi. 0 to 1. Because what is sin ax integral? Minus cos ax by x coefficient. Apply upper limit. Lower limit. Cos 0 is 1. Cos pi minus 1, minus into minus 1 plus 1. 2 by pi. So what is the answer? Answer is 2 by pi. Another interesting question. With this we'll stop. Last. Limit tending to infinity 1 by n sin square k pi by n. Yes. Dash. Don't write 2 by pi whole square. Nobody will write as max. They're all max students. You're here means you will not do such mistakes. Sin k by n is 2 by pi means don't write sin square means 2 by pi whole square. This is not correct. To our surprise, we get one interesting result. Let us see. This is limit n tending to infinity. K is 1 to n. 1 by n is out. Sequence. Summation. Sin square pi into k by n into pi, or pi into k by n, as before. This is in the form 1 by n summation f of k by n, where f of k by n is sin square pi into k by n, f of x. This is 0 to 1 fx dx. 0 to 1 sin square pi x dx. So how to do this? Any one of you? Any idea? How to integrate this?
1 minus cos 2 pi x by 2.
So sin square theta 1 minus cos 2 theta by 2. Instead of theta, you are having pi x. So 1 minus cos 2 pi x by 2. 1 by 2 can be taken out. 0 to 1, 1 dx. 0 to 1, cos 2 pi x dx. 1 by 2, this is x dx. X 0 to 1. Cos 2 pi x is sin 2 pi x by 2 pi. 0 to 1. This will be 1. Lower limit is 0. For this sin 2 pi, upper limit, lower limit is sin 0, which is 0. Sin 2 pi is 0. Sin of anything into pi is 0. Standard result again. Sin n pi 0, sin n pi 0, sin 2 pi 0, 3 pi 0, 4 pi 0, and so on. So what is the answer for this is 1 minute. This is the answer. So with this, we have completed one set of questions which we can expect. So which you don't know. Most of you might not have done all this in your academics. So I'm concentrating on the questions which are coming in the exam, not covered in your academics. That's where I'm concentrating. In the next class, tomorrow's class, we will see the theory part behind this, how the theory questions appear. So we have done so many questions. So now we are confident that you can do some problems. Again, it's a break only. In between, some theory we'll do tomorrow and enter into the next concept. How to check whether a sequence is monotonic sequence or not. How to check whether a sequence is bounded or not. How to see whether some certain sequence are convergent or not. So because you are getting questions, you are giving some sequences like form 3n plus 2 by 4n plus 5. Is it the sequence is option A monotonic, option B convergent, option C bounded? Like this, you are getting questions. So how to work out those questions also, we will try to do tomorrow. Okay. Thank you very much.
Thank you, madam. Any doubts? Any
Any
clarification
doubts?
regarding today's session? Please interact with madam. Actually, time is 9:30. If you have any doubt, please feel free to ask. సో మీకేమైనా ఇంకో క్వశ్చన్స్ సిఎస్ఆర్ కానీ టీజీ సెట్ లో గతంలో ఈ మోడల్ మీద క్వశ్చన్స్ అడిగిన క్వశ్చన్స్ మన వాట్సాప్ గ్రూప్ లో పెట్టండి. మేడం విల్ డిస్కస్ ఇన్ ద నెక్స్ట్ క్లాస్. లేదంటే మనం ఆన్సర్ చేసి పెడదాం. మన వాట్సాప్ గ్రూప్ లో పెట్టండి. ప్రీవియస్లీ ఈ మోడల్ మీద వచ్చిన క్వశ్చన్స్ ఏదైనా కూడా గ్రూప్ లో పెట్టేసి. థ్యాంక్ యూ వెరీ మచ్. గుడ్ నైట్.
Right. Thank you.
Good night, all of you. Yeah. Yeah, good night. Madam, share చేయండి మేడం నోట్స్ ఒకసారి.
నేను చేస్తాను. ఇప్పుడే చేస్తాను.
సో సేమ్ టైమింగ్స్ రేపు ఆ టైమ్స్.
ఏమైనా డౌట్స్ ఉన్నాయా? Any doubts?
No doubts. Yeah, Anusha, Amulya, Anjali. Yeah, Pooja. Pooja, I think degree అనుకుంటాను. Pooja?
Yes, sir.
Yeah. ఎలా ఉంది క్లాస్? ఎలా ఉంది? ఓకే, ఫాలో అయినవా?
Yes, sir.
నో. కొంచెం
Thank you,
బేసిక్స్
sir. Chala. Yes.
కొంచెం బేసిక్స్ చదవాలి.
Okay, sir.
నేను వీడియోస్ మీకు పెడతాను. నేను ఫస్ట్ సెకండ్ క్లాసెస్ విన్న తర్వాత ఇంకా కొంచెం మీరు ఎంజాయ్ చేస్తారు.
Okay, sir.
ఓకే.
Thank you, sir.
యా, గుడ్ నైట్ ఆల్ ఆఫ్ యు. మల్లేశ్వరి, గుడ్ నైట్. నగేష్ ఓకేనా? వంగాల నగేష్ ఫ్రమ్ కాకతీయ యూనివర్సిటీ. నైస్. ఓకే, గుడ్ నైట్ ఆల్ ఆఫ్. రేపు సేమ్ టైమింగ్స్ అండి. రేపు సమ్ టైమింగ్స్ వచ్చేసి సేమ్ 8 స్టార్ట్ అవుతుంది సెషన్. నైస్. ఇంకా ఎవరైనా ఉంటే మీ ఫ్రెండ్స్ కి షేర్ చేయండి. సిఎస్ఐఆర్ ఐఐటి జామ్ కానీ పీజీ సెట్ ఎంట్రన్స్ కోసం సిపిజెట్ ఎంట్రన్స్ రాయాలనుకున్న విద్యార్థుల కోసం, ఎందుకంటే మనీ పే చేయలేరు, కొంత పూర్ పీపుల్ ఉంటారు, వాళ్ళ కోసం హెల్ప్ చేయాలనే ఉద్దేశంతో ఈ ఫ్రీ కోచింగ్ ఇచ్చాము. బట్ కండిషన్స్ ఆర్ అప్లికేబుల్. ఫ్రీ కోచింగ్ తీసుకునే వాళ్ళకి కండిషన్స్ ఉంటాయి. దాని ప్రకారం సిస్టమేటిక్ గా వర్క్ చేయాలి. వాళ్ళకి మాత్రమే అవకాశం ఇస్తున్నాం. మీరు మీ వాట్సాప్ గ్రూప్లలో ఇన్ఫర్మేషన్ పాస్ చేయండి. ఎవరో ఒకరికి, ఒక పేద విద్యార్థికి ఉపయోగపడవచ్చు. తద్వారా మిమ్మల్ని ఎప్పుడు గుర్తుపెట్టుకుంటారు. ప్లీజ్ దయచేసి మీరు మీ వాట్సాప్ గ్రూప్లలో ఈ ఐఐటి జామ్ ఫ్రీ కోచింగ్ ఇన్ఫర్మేషన్ పాస్ చేయండి. ముఖ్యంగా ఐఐటి జామ్ దాదాపు 2% ఆఫ్ స్టూడెంట్స్ కూడా మన తెలంగాణ, తెలుగు రాష్ట్రాల నుంచి అప్లై చేస్తలేరు. వాళ్ళ కోసమే ఈ ఫ్రీ కోచింగ్ అనేది పెట్టడం జరిగింది. అవేర్నెస్ తీసుకురావాలి. ముఖ్యంగా అవేర్నెస్ ఎక్కువ తీసుకురావాలి. ఫర్ ఎగ్జాంపుల్ ఎన్ఐటి వరంగల్ ఉందనుకోండి, 60 సీట్లలో ఒక్క సౌత్ క్యాండిడేట్ కూడా ఉండలేడండి. అంతా నార్త్ సైడ్ లో వస్తున్నారు. దానికోసం అనే రిక్వెస్ట్ చేశారు, అవేర్నెస్ పెట్టండి, కొన్ని క్లాసులు పెట్టించండి. అట్లీస్ట్ ఒక రియల్ అనాలిసిస్, లీనియర్ ఆల్జిబ్రా, ఓడిఈ ఒక 3-4 టాపిక్స్ ప్రిపేర్ అయితే ఈజీగా క్రాక్ చేస్తారు. రైట్ సార్, గుడ్ నైట్.